So today we are actually going to talk about the awesome world of algorithms, computer science, and how it impacts system design plus our lives. In my opinion, this video is going to be quite interesting, quite useful, and we are going to learn 10 real life systems to see that how algorithms are actually helping us achieve great things just by simple set of instructions. So without any further delay, let's just get started. So the first question comes to our mind is that what an algorithm is. And in my opinion, algorithm is nothing short of a simple set of instructions that a computer needs to follow in order to complete a task. Now, think of it like creating a recipe for your favorite dish, but instead of baking a cake, your computer is actually creating videos like this, or it's finding the shortest path between any two places, let's say your home and your favorite restaurant, or it is helping you search through Google, it is helping you buy things on Amazon, being having it delivered to your home. Algorithms are everywhere. Algorithms are nothing but the ability to solve problems, defining the steps for that, and implementing the steps for that. Now, I actually wanted to talk about the types of different algorithms and their characteristics, that what defines a good algorithm and what are the things you should consider. But in my opinion, most of the people are already going to be familiar with this approach, and I'm going to talk about these types of algorithms and I'm going to talk about these characteristics of algorithm. If you want, you can go and check it out. I'm going to put this in the end of the video. And if you already know that stuff, I think we can start moving forward and start discussing the real world problems. Now, the first example we are going to see where algorithm played a significant role in achieving a tremendous large scale system is going to be Google's search. Google is one of the most powerful web browser out there, probably the most widely used, and it's $1 trillion company. But originally, the whole search for web engine actually came through an algorithm called PageRank that was originally developed by the owner of or the founder of Google, Larry Page. And in the Larry Page's PageRank algorithm, he wanted to define that how does a system in any search engine like Google defines that which web page is important, and in order to do that, he started ranking all the available web pages in some sequential manner. So the previous web browser, they only used to search about the value that is currently present inside any existing page. So say for an example, I currently have 4 web pages, A, B, C, and D, and I want to associate it with word cat. So what previous web browsing used to do is that they would see how many times word cat actually appears in each one of these web pages. So let's say that we get some arbitrary value like it appears 1, 2, 3, and 4 times in 4 different web pages. So according to their occurrence, the previous web browser would deem the web page number D to be the most important web page, and then it would show that as the result. But Larry Page had a different approach with his PageRank algorithm, where he would consider these as actually nodes inside any particular graph and try to see that how many values are there that are actually pointing back to any particular web page, and depending on that value that has been pointed back would define the importance of that page. So assume in this scenario, if all of these 3 web pages, they point back to page number A, and then only 2 web pages point back to web page number B, and only one web page points back to web page number C. So according to the PageRank algorithm, actually A would be the most important PageRank because it has been referred by 3 other web pages. And this was a revolutionary idea, that this PageRank algorithm was the foundation for the Google, and it actually occurred most probabilistic, most realistic result that actually built Google what it is today, essentially a $1.5 trillion company. So you can imagine that how important it is to define an algorithm and come up with the solution. Now, second example we are going to see is the Amazon recommendation engine. Now, Amazon has millions of products, and we are actually able to find the results we are looking for quite quickly. So let's say that I'm a user, I'm currently browsing through Amazon's website, and if I'm somewhat a regular user, Amazon would have learned my preferences about what are the things I want, what are the things I like. Let's assume that in the past 15 days, I actually bought a washing machine. Then Amazon would predict that now I might need a washing machine liquid or washing machine detergent. So there would be suggestions coming based on that. So the recommendation is actually quite good. And for that, Amazon actually using an algorithm called collaborative filtering algorithm. How does the collaborative filtering algorithm works is that it takes or it predicts a user's preferences. So it tries to predict the preference of user based on the past ratings of the values that has been purchased by the user. So in our case, a washing machine. On top of that, it also checks that what other people have bought with washing machine. So let's say that there are 500 other people who actually bought washing machines, and within 10 to 15 days they started buying the detergent. So Amazon would automatically learn that for me it would make sense to be shown the picture or the suggestion of a detergent, that this would be the most likely purchase I'm going to buy next. And this includes a lot of things, not only in terms of the purchase history but also the festive season or the seasonal changes. On top of that, new announcement in the world. So let's say that if iPhone 15 gets launched, then suddenly I would start seeing all the recommendation for new iPhone cases. And if I bought a new iPhone case, which means Amazon would predict that next I might need a screen guard for the iPhone 15 as well. So it will start showing me these results, and how these collaborative filtering algorithm actually makes the user experience and the probability of user buying more things from Amazon much more likely. And that's what made Jeff Bezos one of the richest person in the world. So now you can start to understand the power of algorithms. Now let's start talking about the Facebook and Twitter news feed. We all know that on both the websites there is a countless number of user feed and user stories that we can see, and we can keep scrolling down and down, and they tend to be more engaging towards the user. And how this user feed is actually doing that, it is actually it actually has a lot of machine learning algorithms working in the background that is going to predict that what does any particular user's engagement looks like. And this engagement actually depends on users personality, location, where they live, how they live, what are the previous things that they have liked in the past, what similar accounts or what people in the similar groups that that person is associated with, how many things they are liking. And then that keeps on building the new feed over and over, that you can keep on consuming and keep on watching. So there are a lot of issues associated with that, but that's a whole separate conversation. We are currently strictly talking about algorithm and technical and system design aspect. So in that regard, this approach is actually quite wonderful, and if anyone wants to, they can actually do PhD in these subjects. That's how broad and that's how long these things take to develop over the time, because they are dealing with like petabytes of data. Now, next application we are going to talk about is actually Google Maps route optimization. One of the very popular and very key application where we can actually see that how a typical graph based algorithm works and functions and also shines. So typically in any Google Maps, usually there are 2 points plotted in any particular city, and we wanted to find the best, shortest and most efficient distance between any two routes. On top of that, Google Maps also provides us the functionality that we can choose the walking path, or we can choose the path with like bicycle, or we can also choose the path with the public transport. So all of these functionalities have their own sort of variations and versions, but let's talk about the basic principle of what type of algorithm is being used over here. Essentially, every single plot in this is actually treated as a node inside the graph, and for these node we want to find the shortest distance. So shortest distance can have many meanings in this. There can be the distance that has the shortest physical distance, then there is shortest time algorithm, then also there could be an most optimal distance, which is shorter and yet does not go through any toll roads. So all of these considerations are feed into the data that is generating or providing us the suggestions. On top of that, this Google Maps route optimization actually depends upon the live traffic plus live road events. So what do I mean by live road events? Let's say that there is a crash suddenly being detected, or there are some lanes that got closed on the road. So all of this is also taken care. So this is actually a great example of graph based algorithm where typically the concepts such as Floyd Warshall is actually being used to find the shortest path. On top of that, it used quite a lot of dynamic programming to come up with all of the basic functionality and advanced features and advanced functionality, or provide their services to millions of people all across world. So that's a mind-boggling event if we think about it. Next is one of again my favorite companies, Netflix, and the service this time we are talking about is actually next Netflix streaming. So in this case, we are typically talking about that how does a content buffering system works, because we all know that Netflix actually has petabytes of data that it needs to route all across world, and this usually is taken care of by three regions that are currently located on AWS, and these three regions essentially serve all the 200 million people. So Netflix has to be really careful with how it buffers its content and submits it and push it to for everyone to watch out. So usually for this, it uses something called adaptive bitrate streaming. And what does adaptive bitrate streaming means is that it takes care of all the streaming that is happening through the system that dynamically adjusts the video quality and dynamically adjusts the stream quality between a server and a client. So assume that the client is actually having great internet and it has a lot of bandwidth available, and server is relatively close by, and server is also working at an optimal function. We will typically get like 1080p or even 4K video quality. Then all the streams and all the packets gets routed quite efficiently, but suddenly something happens or their client starts facing issues with the internet connectivity. In this case, Netflix does not suspend its operations, but rather instead, if it's serving 4K, it will probably start sending out 1080 packets. If not, it might send out 720 pixel packets. And you know, the funny thing is that all of these are actually stored in separate files. So let's say that we have a movie called Wednesday, and for this movie there would be actually a file that is compatible with iPad, there would another file that is compatible with mobile, and for each one of the version there would be 4 or 5 separate files that would have all of those different bit rates. So imagine a scenario where you are watching this movie, you are currently on the 50th minute, suddenly you are watching it in the iPad, but the iPad battery goes down, so you start watching it through your mobile. So automatically Netflix algorithm is going to pick that from your iPad you are actually watching at 50th minute. Now it will go to the mobile, it will bring out that appropriate mobile file with the appropriate quality and start showing you that result. And suddenly Netflix realizes that your mobile is having an issue, so it will start decreasing the quality, and maybe it will start sending out 720 pixel. So pick another file and then submit and show you that movie, and all this happens dynamically. So quite an amazing feat that Netflix has able to achieve, in my opinion. Now, next, one of the popular algorithm is actually YouTube's video recommendation, and this is literally daddy of AI, in my opinion, because YouTube is so huge, so diverse, millions of watch hours worth of content, and yet you are always being suggested with most engaging and most captivating pieces of content. So that's why it's pretty good. Everything is dynamic, and the algorithm that YouTube typically uses is usually a deep neural network algorithm. So it has its own, YouTube has its own algorithm that keeps track of the user engagement and user viewer activity and user preferences plus events happening outside the world, and combining that, it generates the feed of all the YouTube videos that anyone should start watching, and then build out those feed depending on the individual users. And the funny thing is that YouTube is actually a free service. Like, you don't have to essentially pay for it, you watch the ads, but still it's a free service. So it's mind-boggling to imagine that this deep neural network recommendation algorithm is actually quite good. Next one is pretty good because I used to be an Uber driver and I have done it many times, so I'm quite aware about how frequently Uber changes its search price, and you can clearly see. So typically Uber has what it's called zones being divided for any particular city, and depending on the number of drivers in that area plus number of people requesting Uber rides, if there is a mismatch between demand and supply, automatically we would see surges happening. But these surges are not going to be that for this entire zone currently there is a 2 times surge going on. Usually the surge would be something like a cloud of array, where somewhere in the middle it would be higher surge, so maybe 3 times the surge. Sometimes on the outside maybe it would be 2 times, sometimes on the outside it might be like 1.2 times, something like that. And all of this happens completely dynamically. So this surge pricing algorithm is surprisingly good, because it has to take into the account of how many number of people are actually requesting the Uber, plus how many number of people or how many number of drivers are available in that particular area, and how busy the traffic is, what day or what night time there is going to be, and depending on that it dynamically keeps on adjusting surge prices. So you must have experienced that if you see a lot of surge, maybe if you just wait for like 10 to 15 minutes, suddenly the surges tend to go down, if because there are usually more number of drivers rushing into that surge area, and eventually there would be more drivers compared to the number of people requesting the service. But overall it's a pretty spectacular piece of technology. Next one, again very popular one, Tinder's matchmaking algorithm. And this is actually being done by using something called elo score system. And what does elo score system works is that algorithm actually ranks every single individual person based on their attractiveness and their engagement on the platform. So how often they have been in the member, are they a premium member or not, have they posted more of their photographs, have they provided more information, are they like a 6'5" male who is like well built compared to someone maybe like my size and my body weight. Their preferences and their ranking would be different on the Tinder matching profile, and depending on that you would see various suggestions on the Tinder. So whenever you're looking for that next match, maybe for eternity or for the next night, in either cases Tinder is actually doing quite a good job of generating the preferences based on the ranking and the information it has provided. So again, very good algorithm to study and understand. And don't worry about it, all the systems that I'm talking about and explaining, I'm going to make separate videos on every single one of them, breaking down each and every component. But this is, we are just trying to understand that how different systems operate on different types of algorithms that has different characteristics and different functionality. So next one on our list is actually banking fraud detection system. A very important piece of information, because as the increase of hackers, they are always trying to break into people's networks, people's credit card account, people's domain. So in that, most of the popular banks have actually created their own fraud detection system, and this is usually an anomaly detection system. So how does the an anomaly detection system works is that it checks that any transactions that are happening, are there any possible red flags, are they being originated from some unusual area on the world. So let's say if someone suddenly starts accessing my account from North Korea, banks are going to expect that there might be some anomaly over here. So let's detect that and let's treat it as a potential threat. So that could be one example. There could be another example where one person has an account and he or she is trying to log in, but the password keeps on failing over and over and over. So maybe after like 3 to 5 tries, automatically it's going to say that I think there could be some possibility of fraud over here. So there are a lot of systems that works quite integratively with each one of them, and that's how this algorithm essentially works. So these were my examples that I was talking about, and I hope I was able to convince you that what are the changes that are there, how algorithms are actually important to the system design, and how you can also start learning it. Also, in the next couple of weeks to a month, you are going to be seeing me making bunch of different algorithm related videos and system design videos. So we will break down all of these components one by one by one, and I can understand that this video had a lot of information to take in. I just wanted to ask you take a breather and maybe try to slow down. If you feel that I rushed into anything, or if you have any opinion about the way I explain things, feel free to mention it in the comments. I'm always open for suggestions, critiques, and trying to make better and better content over the period. So hopefully you enjoyed the conversation. So first let's understand that what are the types and categories of algorithms. Number one category of algorithm is sorting algorithm. Sorting algorithm does sort elements. It can be random numbers and it sorts it in ascending or descending order. It can be random colors and it sorts it in the frame of a rainbow. It can be characters and it creates in a form of dictionary. All of these things can be achieved via various set of sorting algorithms that we have, and we don't want to go into nitty gritties of what each algorithm does. Maybe if you want, I can create a separate video on that. What I want to put more emphasis on, that how different categories interact with each other. So one category we already talk about, sorting. Next category is searching algorithm, and there are many ways to search in between given any inputs. One is a linear search. So let's say if you have something like an array, you would probably do a linear search. If you have a sorted array, you would probably do a binary search that is going to significantly improvise on the time. But the predeterministic condition is that you actually need to have the input sorted. So see the correlation and see how you can solve a problem by some other characteristics. So we are going to build a lot of things on top of that. But let's just get back to the types of algorithm. So on top of that, there is if you have a graph like data structure, or if you have random nodes that you need to search meaning from, there are algorithms like breadth first search and depth first search. In the worst case scenario, like traveling salesman problem, there is also an algorithm for exponential search. But all of these algorithms essentially leads us to some search results, and that brings us to the next category, and that is graph algorithms. Graphs are one of the most significant and my favorite data structures. On top of that, graph has a lot of important information that you should at least know the names. You already know what it does. It connects any two endpoints on the node and on the graph, and it can perform things like finding meaning between any two person on LinkedIn and seeing that what degree they are connected with, or finding the shortest path on Google. But essentially all of this translates to graph related algorithm, things like Dijkstra's algorithm or Kruskal's algorithm. There is also Belmont and Ford algorithm, Floyd-Warshall algorithm, Prim's algorithm, and topological sort. So these all would fall under the graph category. Then one of my favorite types of algorithm, that is dynamic programming algorithm. Essentially, we are utilizing the results that we have already computed to generate some sort of answer and find meaningful information. I have a lot of videos on dynamic programming, so if you want, go ahead and check it out on that. Next, there is greedy algorithm, and all the things that greedy algorithm does and focuses on is to trying to find and achieve the maximum number of hops that leads us closer to the result. That is the only aim, that is the only intuition, and there are many problems where it is quite useful. On top of that, there is divide and conquer algorithm, where you actually start breaking down problem into smaller pieces and then start dealing with that. There are some randomized algorithm where you use randomized property that actually helps you quickly sort through a given random number, or do a randomized binary search. So that are quite actually helpful in very specific scenarios. There are some parallel algorithms as well that runs in parallel with each other and helps you achieve the results significantly faster, just because you are using the things like matrix multiplication, where you have separate cores that are running separate set of inputs and separate set of results, and you can actually quickly calculate the answers. There are few of the compression algorithms as well that makes creating videos like this possible, where we create or we generate large number of files, but that actually gets shorted down and being able to transport it over the internet. So you can imagine how useful that is. And next one is cryptography algorithm, that is your RSA token, SHA-256 cryptography. And right now, with the rise of quantum computers, we are also going to talk quite a lot about many different types of quantum computer based cryptography algorithm. So there is a whole discussion on its own, but imagine that these things are coming in. Now, if I haven't bored you to death till now, we are going to now talk about few interesting things, that what defines a good algorithm and what are the properties we can judge it by. So going through the characteristics of algorithm. So number one characteristics is time and space complexity. What time and space complexity is essentially the big O we always used to talk about in system design, but you can think of it like that with the increase in the number of inputs, how significantly the output does and how it is closely correlated with the number of inputs. So if let's say the number of inputs grow from 1000 to 1 million, does the output take that much amount of more time, and is there a linear connection, or it takes essentially no effects, or just because of increase of 1,000 to 1 million users or 1 million input, the output actually goes in like n square time complexity, and the number of steps required to complete or perform that task actually becomes significantly higher. So there is a very close correlation between time and space complexity, so that helps you define what type of algorithm you are creating. Next one is the correctness. Next one is the correctness. You want to check that the algorithm generates the correct result irrespective of the input. So that is a very important property to have. You also wants to have a deterministic property associated with your algorithm. And what do I mean by deterministic property? At every step of the way for your algorithm, you should know that the answer that is being generated is actually predetermined with some set of rules. You don't want to create or have randomized inputs being in place, and this property will help you build your algorithms quite significantly. You also wants to have the property of finiteness, that you either wants to have a zero or more than one input coming in, so a finite number, and same goes for the output, that you wants to create a finite number of outputs depending on the problem you are trying to solve, because infinity is not very useful. Neither it was useful in Avengers, nor it's useful in computer science. Next, let's talk about input and output. Again, same goes, that we either wants to have a fixed number of inputs. No matter, I'm not saying that you just need to have one input or two inputs or zero inputs, but that number should be predetermined based on depending on your algorithm, and same goes for the output as well. And that actually deals with the efficiency. So in terms of efficiency, you want to make sure that you are trying to come up with the best approach that leads or yields the most efficient result. And how do we do that? Depending on the problem, we need to select the type of category of results that we want to pick. One simple example could be that if I want to find the randomized value from the given input, should I just start doing with the linear search, or should I actually try to sort the given input first and then try to find the values? So both answers are correct, but depending on your scenario, you can start making that judgment call. One of the key features that many computer scientists forget or ignore, and that is simplicity. Try to keep it simple. You don't want to have $1,000,000 solutions for a $10,000 problem. So always see that what type of problem you are dealing with, and then come up with the solution. And that same thing would help you generate efficient, scalable, reliable, and performant services. So I think that sums up all the characteristics that we can judge an algorithm by.